All right, so we've completed looking at the completing the square method in terms of solving quadratic equations. This last example is going to look at another application of this process, and that is to take an equation um, that's in standard form and rewrite it in vertex form. All right, so you can use this method to do that as well. And then once you know the vertex, then you can answer the question of what the minimum or maximum is. And remember, it's one or the other. It can't be both, right? So for this example, first thing they did, all right, is subtracted the 1 to the other side to try to isolate the negative 2x squared plus 10x, right, the quadratic and the linear term. Then they factored the negative 2 out. This one worked out nice because the 10 was also a multiple of 2. Then you figure out what completes the square. So in this case, you have to take 5, divide it by 2, you get 2.5. And when you square 2.5, you get 6.25. So that's what you're going to add to both sides. However, when you add it, when you're trying to balance out the equation, when you're adding it inside the parentheses, that negative 2 is also multiplying the 6.25. So that's why you need to include that when you balance out the equation on the left side. Okay. You simplify that out on the right side, you get y minus, well, that'll all balance out to negative 13.5. The x minus 2.5 squared is just going to stay that way. Well, that x squared minus 5x plus 6.25 will factor into x minus 2.5. And then you add the 13.5 to the other side. And then you note that the graph opens downward because that a value is negative. And since it opens down, the vertex represents a maximum, specifically at y equals 13.5. All right, let's take a look at these two examples here. How about we do one together, and then I'll leave the part B for you to try on your own that we can then check at the end. So first thing, let's rewrite the equation. Y equals negative 3x squared minus 9x plus 7. So I'm going to subtract 7 to both sides. That's a 7. And that's equal to negative 3x squared minus 9x. Let's factor out a negative 3. So then you have x squared plus 3x. Now what what's the number that's going to complete the square there? So 3 divided by 2 is 1.5, and 1.5 squared is 2.25. So when you balance it out, again, you need to have minus 3 times the 2.25 on the left side. And then that's equal to negative 3 times x squared plus 3x plus 2.25. All right. Now on the left side, negative 3 times 2.25 is going to be negative 6.75. On this side, you've got negative 3. This is going to factor into x plus 1.5. It will always be that. So whatever the b divided by 2 is always what's going to go here. So you don't even need to really think about how to factor that, because 1.5 is the number that you got to create the 2.25, right? So just back it out. So you have x plus 1.5 squared there. This ends up being y minus 13.75. So we're just going to add that to the other side. So then y is equal to negative 3 times x plus 1.5 squared, and then plus 13.75. identify the maximum or the minimum. So in this case, it's a maximum again, because that -3 makes it open down. The maximum value would be at 13.75 as a y value. Okay. So why don't you pause it and try part B. So let's take a look. First thing I did was subtract the 9 to both sides. Then I factored the 2 away. So you have 2 times x squared plus 6x. Then it's a matter of what completes that square, and it would be adding 9. Again, since the 9 is inside the parentheses, it's getting multiplied by 2. That 2 needs to be included in balancing out the left side of the equation. So 2 times 9 is 18, minus 9 is plus 9. So you have y plus 9. That x squared plus 6x plus 9 factors into x plus 3 squared. Then you subtract 9 to both sides. And you have y is equal to 2 times x plus 3 squared minus 9. So that's your equation in vertex form. So the vertex is -3, -9. This one opens up. So this one's going to have a minimum at -9. Right? The exit ticket we're going to do in class on Tuesday. So don't worry about that right now. Just get the notes completed by class on Tuesday, and we'll do the exit ticket together tomorrow in class, and that'll be it. All right. So let me know if you have any other questions. Otherwise, we can talk in class.